We first need some variables that we're going to be testing. When we're talking about my brakes, what are my two averages going to be? mu1 and mu2. If we're talking about my brakes and my bike, what are my two averages going to be? I think Cassie mentioned them earlier today, but it's about an hour ago, so we may have forgotten. What's mu1 going to be? What's mu1 going to be? Think me, Max, that hill, my bike. Why did I even bother doing this experiment?
That's different.
Say that again, Eric. Well, good, but what is mu1? That was x bar 1. What am I interested in mu1, which I'm never going to know? What is mu? Average, yes. Average what?
Braking distance.
Braking distance for? Average braking distance for cantilevers. Those of you guys that don't care about bikes, just call it brake 1. That's fine too. What's mu2? What's mu2?
Average braking distance for
Mm-hmm.
brake 2.
Exactly, for brake 2.
Yeah.
Exactly. Average brake distance for brake number 2, or linear pull. Brake number 1, brake number 2, that's actually easy to keep the 1s and the 2s together. What am I interested in? What am I interested in?
Are they different?
Are they different? Are they different? And in particular, I'd like to go even stronger than that, Will, if it's okay. Because I had a theory based on my online research that what?
Linear pull.
Oh, it's going to be better.
These guys are going to be better, which means this guy should actually be less than this. So are they different? Yes, but even better, my hypothesis that I want to test, HA or H1, I think we can go ahead and test the fact that mu2 is going to be less than mu1. Yeah? mu1 bigger than mu2. That's what I think we're going to test, yes? As soon as I put some more ink in this marker. Everybody follow that logic? What's the null going to be? Huh? What's the null hypothesis going to be? Say it again, Rosie. That they're even. Or the cantilevers are better than the V-brakes, yeah?
Can I turn this light on?
Of course, Justine, I'm sorry. Yes, I was going back and forth so much with the computer. So there's your research hypothesis. Your null hypothesis, H0, is going to be that they're either the same or worse. But we'll go with equals, because that's standard, industry standard. There's your hypotheses. There's your step 1. What are step 2 and step 3 going to be based on the exam you guys just got back? And this doesn't change at all.
Statistic and p-value.
That's perfect. That's it. That doesn't change at all. The only thing that changed is how the test statistic is calculated. We have to make sure we have the correct nod to the data and we're measuring it correctly. We'll go.
Little thing, was your guess that the brake 2 was going to be better?
Better, which means less braking distance.
All right.
This is great. This is why you have to define the variable so carefully, right? You have to make sure you're measuring it as, is it perceived braking power? Is it better braking power? I couldn't measure that with what I had, but I could measure braking distance. Thank you, sir. Good, good. And that's important because this only measured me braking without a skid on pavement. It didn't measure anything else. It didn't measure braking power. Didn't measure rim to metal or pad to metal contact, anything like that. That would probably be reversed, wouldn't it? But this is just braking distance. Thank you. Very, very good. Very, very important to define those variables. Step 2 and step 3 are going to be the test statistic, which is going to be T, and the p-value, which is going to be the big P. We are not going to calculate that manually. Hell no. For 2 reasons. Number 1, if students screw up a normal t-score, they're always screwing this thing up. And number 2, there is something that you have to use with t-tests. It's called degrees of freedom. Degrees of freedom. which is based on your sample size. I made mention, exactly, Rachel. I made mention of it a few weeks ago. I mentioned it back in 243 once, very, very briefly. We talked about it briefly back with the beginnings of T intervals. Do you remember, you can say no to this, when we talk about the Guinness Corporation and how Gossett invented the T distribution, how the curves were changing as the sample size was changing? Remember that? And we split it up, and as they got larger, sample sizes got larger, the bell began to look exactly like a bell curve. That's degrees of freedom. As it changes, the curve changes. So you have to know which curve to use by knowing which number of degrees of freedom to use. Technology does it all for us. We don't have to worry about a damn thing. So all we've got to do is take a look at that t-score. Now what I like to do is I like to think about what the sampling distribution is going to look like, because we're going to get a t-value off of this. What number's in the middle? Always? Always. What does that mean if our data lands right there? What does it mean if our data lands right there? There's absolutely no difference at all. Now here's a bit of a loaded question. As we go from one side to the other, one of the breaks is performing better on average than the other. The trick is setting your data up so that you know which direction you have to go. We are setting this up so that mu1 will be bigger than mu2. So let's run our TIs right now and then come back and see where we land on this curve. Because you can do this two different ways and get the exact same result with two different test statistics. I want to make sure you understand what I'm talking about there. Let me clear some board and show you what I'm talking about. Put it right here. Could you kill the lights, Harrison, if you don't mind, real quick so you can see this? Yes, it's called a two-sample t-test in this case. So it's the same stat, you still got your data in L1 and L2, leave that there. Go stat test, two-samp t-test. Number 4 on mine. Number 4 on mine. Little nod to the two samples. Grab it. Either have data or you have statistics. We have data. We have data. Our data is in L1 and L2, yes. Frequencies of 1. That's what we've got. We've got raw data. We have frequency distributions we can deal with, as we'll deal with those later on today. Mu1, mu2. This is why we painstakingly define the variables. So you know which sign to pick. Because depending on how you define the variables, you could use either one of less than or greater than. But we define mu1 to be the average break distance for the first set of breaks, which we want to be bigger than mu2 if my hypothesis is correct. Everybody buying why that's greater than? Yeah. If you switch them, right? If you switch them, it would be less than, but you have to switch your data in your lists as well. Does that make sense? That makes sense. It's kind of like that matched pair test you guys just did on your test. Whether you did L1 minus L2 or L2 minus L1. Both are correct, as long as the sign that you pick represents that. Is that fair? We're getting there. Okay, this pull thing, ignore it. Always leave it on no. I have never seen one good reason why you should do what's called pulling variances in a hypothesis test. So you can ignore that. I think it's a holdover from antiquity. Okay, you ready? Scroll down. I'm going to do one thing first, actually. I'll turn my plots off from 105. Okay, scroll on down, scroll on down. We're going to draw this bad boy. Here he comes. There's your axes. Now, it's a right tail test, yes, with the greater than sign. Look for area on the right side. Look for area. I don't see a whole lot. 12. The hell is 12? 12 what? 12 what?
It says P is 0.
It does say that. What's that? 12.6. Oh, sorry. T is 12.6. P is 0. I'm so excited about 12.6. What is a 12.6?
Are those the standard deviations?
Standard deviations away from average. The average should have been 0. The average should have been 0. If, assuming, of course,
Assuming the null.
that they were the same, assuming the null. What does this tell us? Should we believe the null hypothesis? Oh my God, no. My God, no, we don't believe the null hypothesis. With 12.6 standard deviations, we're way over there. Which means, essentially, this is the breaking curve for linear pull breaks, for breaking distance. And there's a whole other curve over there. Whole other curve over there. That is the breaking distance for cantilever breaks, which is significantly higher. Statistically significantly higher. Cassie already gave me it's about a 5-foot difference. minimally, about a 5-foot difference. But that 5-foot difference represents 12.6 standard errors in the sampling distribution. Pretty wild, pretty wild. It's up to you to decide if that 5 feet, i.e. 12.6 standard deviations, is worthwhile. For me, it's totally worthwhile. I don't crash on trail riding anymore. So yay, I come down there fully in control of myself. I let the bike down and jump out of it. But statistically significantly, there's a humongous difference. What would your conclusion be? What would your conclusion be at this point? It either appears or does not appear. Go ahead, Eric. It appears.
Appears that brake 1's better than brake 2.
Careful.
I mean,
When you say better, what do you?
less of a stopping distance.
Good. It appears that these brakes have less of a stopping distance than these brakes here. Good. Sorry about using the jargon. But yeah, it appears that my linear pull brakes have a lower average than my cantilever pull brakes.
Yes.
Boom. Done. I get technical tall max now. Cool? Makes sense? The point of this wasn't so much just crunching numbers into a TI. You guys could have done that an hour ago. You could have. You could have. The trick is knowing what the hell the TI is doing. And what it's doing has to weight both of these variables. It has to weight both of these variables. It's important. It's extraordinarily important, actually. Ask the questions if you got them right now. Will, ask me that question. Oh, just scratch your head. Sorry. I see motion.
Can we go through the type 1, type 2 errors?
Yes! First of all, thank you, Ashley. What kind of error could you have made here, based on this conclusion? Type 1, which would mean what? In context, though. What would the error be in context? We're making the claim that
They have a shorter stopping distance.
when,
In fact, they don't.
in fact, they don't, which means maybe I just got disparate data. Maybe Max was really biased in my data collection, and I screwed it up. Maybe he was somehow influencing. Maybe even though I tried not to, my brain was trained to do better with the V brake, so I wasn't going to do that good. Or just random. Just randomly got. So that's type 1. Type 1's false positive, saying that the brakes are actually better when in fact they're not. Okay. Going into the experiment, what would a type 2 error have been? Not that we could have made it with our results, but what would a type 2 error have been? A consideration for it would have been going in. Saying that
There's no difference.
there's no difference when in fact there is. Saying that there's no difference when in fact there is. Which of those two types of error do you think is more severe in this case, friends? This is me asking you your opinion. A false positive or a false negative? Coming from this point of view of bike safety. What do you think? False positive or false negative? Tell me why, Eric. I'm thinking the same thing. Tell me why.
Well, because if you didn't think that there was a difference and you slam on the brakes for the LPs
Yes.
and you just kind of skid off or fly over your bars or however it works, I don't know.
Exactly. You go to the handlebars if
Yeah.
you grab them the right way or the wrong way, I guess.
Yeah, and if you would have been aware, you could have prevented your fall.
This is exactly why, in my opinion, in this experiment, although neither of them is as severe as like side effects of a drug or something like that, I think a type 2 error would be a little more significant for me personally. If I came to the conclusion that there was no difference in the brakes when in fact there was, in fact linear pulls were better, then I wouldn't change them. I would leave the cantilevers on. And what was the whole point of my doing this experiment in the first place? Because I wanted to stop better. If I missed that in my test, then I won't change the brakes, which means I won't stop better. Which means I could crash into trees off of trails. I was riding home from work last Thursday night. Thursday night? I think it was Thursday night. On that trail, 7 o'clock at night, coming back on that. It's called the Sawyer Uplands Trail. It comes off Aubrey Butte down to Sawyer Park. And I'm flying along the trail, and 100 feet in front of me, I thankfully stopped a baby stroller sitting in the middle of the trail. 7 o'clock at night, scared the piss out of me. Because the first thing I think of is a baby stroller. There's nobody around it. Is there a baby in that stroller? So my heart's racing. So I go and I look in the stroller, it's empty. I'm like, oh thank God. And then I'm like, heart racing again. Is the person and their kid down the cliff? This is a cliffside trail. If you've ridden this trail before, it cuts across a cliff. So the whole time you're up there, it's a beautiful trail to water ride. But it's the last place on earth you want a baby stroller, especially an empty one. So then I call the cops. I call 911 non-emergency, and I turn my headlights on, grab one off my bike, and I start looking at the base of the cliff, thinking, please do not find a body or two down here. So I'm freaking out. Point of the story is, If I had my cantilevers on, I would have run into the goddamn stroller instead of stopping before I got to it. Because I was going about 20 down that trail when I saw it. But I was able to coast back, drop my butt over the seat, get the speed down. So I think a type 2 in this case would be a little more severe than a type 1. A type 1, false positive, I say there's a difference, I change the brakes, and maybe I still think there is, so I ride better. You know, I ride as if there is a difference, who knows? Is that fair enough? At least I'm not getting any work, please,
Did you
Rach.
find the kid?
No! I have no idea what the hell's going on. I mean, it was the wrong kind of stroller to have on that trail anyway. It's a little single track, and it's one of those little tiny, hard plastic wheel strollers. Called the cops, cops came out and found me.
That's creepy.
It was totally creepy. I was scared out of my mind.
Yeah.
Out of my mind for an hour. Out there freezing my ass off, just scared like, ugh. And I'm scouring the cliff looking for any sign of it. I couldn't find any tracks. I'm hoping what happened was they just were walking the kid on the trail and realized, this is stupid. Grab the kid, go get the car, come back, get the stroller later. But, anyway, it scared the piss out of me. But I'm glad I didn't run into it. Because that's the whole point of the story. That, and you should call non-emergency 911 in situations like that. I learned that too. So. Also, repeat your phone number twice to them. I gave them my phone number and they said they'd call me back 45 minutes later. They hadn't showed up, so I called them. They said, we've been calling you for 45 minutes. I'm like, no, you haven't. And they said, yeah, we've been calling you. It just keeps ringing and ringing and ringing. I'm like, what number are you using? And they gave me the number back. I'm like, that's your number. That's the number I called to get you. She was like,
Wow.
so repeat your number twice to non-emergency 911. I only have one data point. It's not a good one. Fair enough? That's fine. So yeah, so the consequences of type 1 and type 2, they vary depending on the situation. I think a type 2 is a little more. Ashley, does that make answer your question as far as what they are? Thank you. Thank you. Good? Good? Alright, let's run one more of these and then kick you out of here. I want to do 2 proportions. We're not going to have time to do proportions well. You got your data sheets? Rather than creating new data right now, which is a pain in the ass for average data. Grab your data sheets. We'll go into one of my favorite data sets. ADHD and brain volume. And one of my favorites. It's on page 2. Page 2. Go ahead and read the one about, do children diagnosed with ADHD? Let me get fired. Harrison, if you don't mind firing the light back up, that'd be great. I'll get the